Hello everyone, this is Tushar again with a new topic. Hope you all are doing fine. So before the starting the topic, I want to remind you, please hit the like button and also the bell icon so that you get notified whenever I upload a video. So today we will be discussing one of the major point for a earthing system, that is lightning arrestor. Lightning arrestor, we all know, is a basic metallic body which we install at the height, which can capture, or I can say give us easy, less resistive path to let the sky lightning pass through it and get neutralized in the earth. So let us start. So lightning arrestors are made up of copper, which we all know is a good conductor, or we are considering best for each and every conducting electrical device. So here also we make a 3 to 3.5 inches thick rod and just install it on the top of our building or any infrastructure to save it from lightning, and with some minute alterations to it which can enhance the safety or for our system. So we will be discussing today these points and a small different kind of lightning arrestor, which is known as early emission lightning arrestor. First of all, let us talk about the basic one. We all know that a building which is quite high is most vulnerable to the lightning. So we install the earthing pit, then we install the insulated metal strip to the lightning arrestor, then we install the lightning arrestor. Okay, so there are different types of lightning arrestor. You can find that one is with just spikes on it, one are like some arrows on it, or you can get some metallic strips in rectangular shape. These are the different designs. That doesn't matter anymore. The main thing which matters, which is referred as Indian Bureau of Standards, is the rod, the lightning arrestor rod, and the points. The whole complete this setup should be made of pure copper. Nothing to be mixed or made it an alloy of. Okay, so some of the times some customers say that please reduce the cost and mix some brass mixed copper to it. Brass mixed to copper lightning arrestor, and believe me, the resistance is not as less than as a plain copper. So don't just go for the price, also consider it your own safety. So these here are the simplest one. It doesn't have any kind of mechanism, but the main concern was the second point which I want to discuss, that is early emission lightning arrestor. It is of different shape and size. You can see that it has this kind of structure as well. It has this kind of structure as well. It is like a lotus. It is plain like a rod with a ball inside of it, and it is of plain this kind of also. These all are installed on the infrastructure which are of high capacity or length. In solar point of view, we install these lightning arrestors only where there is the capacity exceeding or nearly equal to 1 megawatt, because it is slightly costly than this one. So we avoid this so that we doesn't get try to as we minimize the cost. So we prefer this one till 1 megawatt. After that, or on 1 megawatt, we install this. So so there is a research which was conducted in France. France in 1992, and which was published in 1995. There is a big research which is being followed from throughout the world. On that research only, these all the companies, industries are working and developing their technology for these equipments, for especially for the earthing purposes. If you want to study, you can search it on the site. It will be available. So now I will be sharing the formula on which you can decide that what should be the length of the lightning arrestor and how much radius it will cover for underneath it, so that you can predetermine yourself that which kind of lightning arrestor you want. So here I have shown the formula of the radius of protection. This is the term you have to understand. The radius of protection means on which the point you have installed the lightning arrestor, the area, the radius around by which the circle is formed by keeping the lightning arrestor as the center, that radius will be considered as radius of protection. Before installing the lightning arrestor, you have to consider that the distance from the protecting site and the lightning arrestor should not be far away. And if you are considering for the solar, it never should hinder the solar light, so that shadow can be visible on the solar panels, which can cause many problems, as you all know, like hotspot and many more. So here I will show the difference between the normal lightning arrestor and early emission lightning arrestor is that there is not mechanism in the lightning in the simple lightning arrestor. It is just a plain path which carries the easy resistance to to give to the lightning, so that it can pass and neutralize in the earth. But the early emission lightning arrestor has a mechanism which makes it more positive on the top, so that only and only that is the point where the lightning will strike. It will never strike any other in any other place rather than on passing from that particular point. So this is why it also has a large radius than normal radius of protection for a normal lightning arrestor. So today we will be discussing the formula of lightning radius of protection, that is root of 2RH minus h square plus delta 2R plus delta. Okay, so RP is basically h into RP 5 upon 5 for the height of the lightning arrestor of 2 to 5 meters. Okay, 5 meters is a quite lengthy, whereas 1 meter is considered of nearly 3 feet. So you can imagine the length of 5 meters if you are installing a 5 meter rod. So this RP5 is the value of RPH if you put the height as 5 meter, which I have shown here. Delta is the triggering time advance, like how if we consider the normal basic lightning arrestor and the early emission lightning arrestor, both of these lightning arrestor, if you install it on the site on the same time the lightning occurs on the sky, so you will see the lightning arrestor will fall on the early emission lightning arrestor before, and after it will strike on the simple lightning arrestor. So the more advanced time you want, so that the lightning should strike on your lightning arrestor, that time you have to consider here. So R is the radius, that is 20 meter is a basically R is the parameter you have to consider. 20 meter if level 1 protection you want from very high protection. Level 1 hazardous situation is very high very high protection, as the at the place is very prone to the lightning. So at that point we need very high protection. So in that position we consider is at 20 meter, and then 30 for high protection, and it goes on like 40 and 50. So this is the basic formula. I just want to give an introduction to the early emission lightning arrestor and the simple lightning arrestor. In the near future I will be bringing more videos on this topic. There is many more things to discuss on this topic, and it is very interesting. So please subscribe and hit the bell icon, and thanks for being so patient, listeners.